And so today I am going to go over the two different ways of doing a t-test. And so you probably know from your lessons, or you should, that there is, in the homework, of course, that there's an independent samples t-test and a dependent samples t-test. And the independent samples t-test is a kind of t-test that compares two separate groups. So the people in group one are completely different than the people in group two. Whereas a dependent samples t-test is one that compares the groups before and after, right? Or at two different times. So it would be one group compared at time one and then at time two. So between different groups within same group, and so the synonyms, and I know I'm summarizing the lesson, synonyms for independent is between subjects, synonym for dependent is within subjects, and paired samples. And so I'm going to use an example today of comparing employability status for people who have taken the NACE competencies, which, if you haven't heard of these are 8 competencies that the National Association of College Employers, I think, they come up with a list of 8 skills that they expect from college graduates in order to be employable, basically. And so it's things like teamwork and fluency in technology and leadership and things like that. And so here at UCF, we have certain classes. I do one of them that integrates these competencies and so on. And so the question for the hypothesis, I suppose, for this study would be that students who take this class or have this class incorporated within their class will be more employable. And so I'm going to go to the whiteboard, actually. And so without showing you all of the data, as a matter of fact, let me do that first. Hold on. So this would be what the data would look like in SPSS. It's a between subjects test. So we've got one group of students who did these competencies and another group of students who did not, right? And so this is group 1 who did it, group 2 who did not. And I don't know if you can see my screen, but I already did a t-test in SPSS. And so I'm pulling the means from the SPSS output. Now, when you are taking your test, and I know I've emphasized this for other measures, but I think that it's important here, you can run a t-test even though you have to do the hand calculations. Just make sure that you show the steps in your hand calculations. Now, for when you do the t-test, you need to have the means and standard deviations, or really the means and the variances. And so if you can get that in SPSS and plug it into the formula, that's okay. You don't have to show that you did the mean, by hand, or the standard deviation by hand. You just have to do the t-test formula by hand. I hope that's clear. Okay, yeah, no worries. Oh. Yeah, okay, so there's 2 votes for the volume being weird. And 1 vote. Hey, oh my goodness, kitty cat. All right, looks like we're also gonna have cat problems. So, okay. Can you hear me any better now? Anybody?
I can hear you, Dr. Wooden.
Okay, thank you, Justin. Everybody else, I know that Amy and Letitia were saying that they had some issues.
Yes, I can hear you now.
Okay, good. Just wanted to double check and be sure. Okay, so going back to the lesson, I showed you that we can get the mean and standard deviation or variance from SPSS. And then we would apply those to the formula. And so let me share my whiteboard with you. Here we go with the whiteboard. So we've got the NACE here. And so I just copied this from SPSS in my wonderful handwriting. And so we've got the people who did the NACE competencies with a mean of 34.2 and a standard deviation of 4.077. People who didn't do the NACE competencies came out with a mean of 28.6 and a standard deviation of 5.487. I think that's a 1 actually. Yeah, that's a 1. That's a 1. Number 1. Okay. So we apply this formula to doing an independent samples t-test. And so all we do, just as usual, is to start plugging in values. So we've got the mean for group 1 is 34.2 minus the mean for group 2, which is 28.6. And that's the numerator, and the denominator has all of this stuff. But just remember that each one of these calculations within it, even though the formula looks big and huge and intimidating to some people, you know, each individual calculation is nothing, right? So, you know, you can add, subtract, multiply, and divide small numbers or big numbers. You guys are big boys and girls. So we're going to do that while my cat insists on sitting on my lap. So, so there were 10 in each group. So the n, of course, is 10 minus 1. And then here, this is the part that tricks people. And I don't want it to trick you, so I'm going to point it out the best that I can. Maybe I'm going to point it out the best that I can. So here, this is the standard deviation squared, which is the variance. Right? And so if you are given the variance, just use don't square the variance, because then you're squaring the standard deviation twice. And that will be very, very wrong. So, so please pay attention to this in particular. Are you given, you know, because in some cases you'll be given some of the information. Like I think you're in your calculations. You know, there's one where you're given the information and one where you're not, if I remember correctly. And so if you're given the variance, just use that. But in this case, we have the standard deviations. And so we have to, poor baby, I love you. And so we have to square it. So it's 10 minus 1 with the standard deviation squared. So 4.007 squared minus, no, plus, sorry, 10 minus 1 times the standard deviation, which is 5.481 squared. And all of that is over, sorry, I have a lot of room here. All of that is over n plus, which is basically your degrees of freedom down here. N plus n1, and for the first group, and for the second group, minus 2 in brackets, because there's a whole other part, but it's actually a really easy part where it's just n for the first group plus n for the second group over n for the first group times n for the second group. And so actually, if we were writing those in, which I guess you already have the formula, so we probably should have just done that. But no problem, it's just 10 plus 10 minus 2. And over here, it's 10 plus 10 over 10 times 10. Okay. And so we just continue to solve for t. So, which I have done in my notes, so I'm not super brilliant at calculating. I just have already done this. But just so you know, 34.2 minus 28.6 is 5.6. And then again, I always forget to take the square root. That's kind of my thing. So I always point that out to students so that you don't make the same mistake. And of course, 10 minus 1 is 9. And we can multiply that. So the variance here is going to be 16.622 plus 9 times 30. This is the variance for group 2, 30.151. And then, of course, 10 plus 10 minus 2 is 18. And so that's all one thing. If we move to the next thing, we should have, oh, it should be 20 over 100. And so just kind of multiplying that out, sometimes I like to just write it kind of on top. So I'm going to pick another color. What did I do last time? Do a different color. All right. So 9 times 149, instead of writing the whole thing out again, sometimes I just like to do this, is 149.598. And then 9 times 30.151 is 271.359. Okay. And so that pink's a bit much. So let's do, what do you think? What do you think? What do you think, guys? I'm gonna do mahogany, why not? So now we have 5.6 over the square root of, so 149.5 blah, 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 plus 271.359 is 420.957 over 18. And then that is going to be times 0.2. Right? That's this part. Okay, and so right, we're just kind of moving right along. I'm going to do purple now. You know, sometimes I need to jazz it up a little bit too. That's too late. Do green. I say T is, what was that? 5.6. Just carrying this over. 23.387 times 0.2. And of course, we don't forget that. Works out to square root of 4.6773, which works out to 5.6 over 2.163, works out to T of about 2.5, right? Yeah, 2.589 is what I'm getting, which is very close to what it was in SPSS. So I'm happy with that. Yay, we got our T. Yes, we did it. Woohoo. So are there any questions about that? I mean, it's just kind of working through those calculations.
Yes, can we go back to the beginning of the problem? Maybe I wrote the number down incorrectly. Because when I calculated it, I like messed up halfway.
Okay, well, I mean, I don't know if I want to go like through the whole thing again, but do you have a specific question about?
1, 2, 3. The third step down, because it says the deviation for the second one was 5.481.
Mhm.
And when we got right there. So when we got right there, when I squared it, I got something totally different. So now I see why I wrote it down incorrectly.
Oh, you did? Okay. That's good. It's like,
Okay.
well, I think it's correct just because
Wait a minute.
5.4 here, I'm squaring it again to 5.481. And then if you square that, you should get, yeah, 30 points. Oh yeah, so I might have, when I did it, might have, let me see if I square.
I have 30.04.
Yeah, I just got that too. So I'm
Okay.
what I think probably happened is, let me see. Yeah, so I wrote, see how I wrote it down wrong at first. So that's what happened. But even, so the 2.589 is really clearly in the t-test from SPSS is 2.59. Right? So we still, like, I didn't screw it up that much.
Right.
But you know, it just kind of shows you. So I would get points off for that on the test, but probably just, you know, 0.5 or 0.25 points, depending. Probably just for this, because there's so many steps, I would get 0.25 points off for that. So I forgive myself. So, but it does show you that writing this down correctly is important. Okay, are there any other questions? Okay, so now that we have the t-value, where's my book though? If we want to know whether or not it's statistically significant, what do we have to do?
I think we have to look it up in the critical value chart.
You're correct.
Yay!
You are awesome. Yes, that's exactly what you have to do. You look it up in the critical value chart, which in this case, with the, what is this, was a 7th edition, is on page 357. And so if you go down to 18 degrees of freedom, I'm going to consider this a one-tailed test because my hypothesis is directional. I'm expecting people who did the NACE competencies to be higher in employability. And so I'll adopt an alpha level of 0.05. And the critical value there is, do CV is 1.734. And so would we consider this to be statistically significant? I'm just gonna be quiet until somebody tells me. So this is our calculated value, our t value. And so we're comparing this value to this value. And so given that information, would we consider the difference, the mean difference between people who took the NACE competency and those who didn't in employability, would we consider that to be a statistically significant effect? One of you just has to be brave and speak up. Oh, come on. I know.
I'm cheating. I'm looking at my notes.
Me too.
That's not cheating. That's a good thing, right?
Well, I know that it has to be lower, correct, than the alpha. The p-value has to,
Yeah,
is
that's the
compared to the alpha.
p-value, right?
So it
So
has to be lower. So,
the p-value has to be lower, but this isn't the p-value, right? So this is the calculated value
okay,
or the test statistic, right? And this is the critical value. And so when we're looking at that, we need this, our calculated value, to be higher. Yes.
higher.
To be higher than the critical value. Good, because remember, the critical value is like the minimum calculated value we need. This table, I know you can't really see it unless I make it my face or something like that. This table in your book is like some nerd went through and listed all of the minimum values that your calculated value would have to be to reject the null at 0.01, at 0.05, at 0.10, you know, for one-tailed versus two-tailed, for 18 degrees of freedom, for 19 degrees of freedom, for 20 degrees of freedom, right? So all this is a table of the minimum you need. It's just like, you know, what's the minimum I need to get through this day or whatever, you know? I mean, we've all asked that question, right? What's the bare minimum I need to survive today? You know, and so this is like our bare minimum table. Right? And so we need our calculated value to be bigger. Now, flipping around to the statistics, what you were talking about, Letitia, I don't think that was, is the p-values, right? And so one-sided and two-sided is the same as one and two-tailed. And so here we've got our t-value, we've got our degrees of freedom. And so here our one-sided p is 0.009. This is the one that we want less than the alpha level because p needs to be small, right? This voice is going to haunt you forever, but yeah. So this is the, this always needs to be smaller than the alpha level, because what this represents is really like the percent chance that, I mean, this is such an oversimplification. I know other stats teachers get mad at me when I say this, but this is basically the percent chance that we're wrong. If our alpha level is accepting a 5% chance that we make a type 1 error, what SPSS calculated is actually, when we're given this data, you have a 0.9 chance, sorry, a 0.009 chance of calculating, of creating a type 1 error. And so you want p to be as small as possible, less than the alpha level, but you want your calculated value to be bigger than the critical value in order to reject the null. So that's something, that little recording you should just like play again in your sleep and forever and ever and ever until you take your test. And then keep playing it, because it'll come up again in research methods in grad school. So it's just something that needs to be embedded in there. But is there any questions now? Do you understand those differences?
Dr. Witten, can I just clarify to make sure?
Yes, of course you can.
Okay, thank you.
I insist that you do.
So when we're evaluating an SPSS output, we are going to be using the p-value and the alpha. Those are the things we'll be comparing to determine if it's statistically significant. I can't talk. If we're doing hand calculations, we're comparing the obtained and the critical.
Yeah.
Okay.
Exactly. Yep.
Oh, good. Okay. Thank you.
You totally have it. Yes. So SPSS, this has to be less than the alpha level. Your p-value has to be less than the alpha level. When you're calculating it, your obtained value needs to be greater than the critical value.
Okay. And then if our t is way off from our hand calculations, we need to go back, right? There's a problem.
If your t is off in your hand calculations versus your SPSS.
Yes.
Yes.
Okay.
Yes. So, so definitely you want to practice a couple times before your exams. And so, yes, if it's way off, like, honestly, I know I made that mistake with the standard deviation there, like not representing it, I guess, as 7, like changing a 1 to a 7. Like if you were only off by, I mean, I don't even think that that would be picked up, to tell you the truth, like of just, a few off like that. So I'd say if you're within a few decimal places, tens, hundreds decimal place, I mean, it's hard for me to give you anything more precise than that, but if it's real close like that, then you're fine. But if instead you got 2 points, 6.9, so that's getting higher, 2.7, that's getting higher. So you should go back, and it's probably something simple. Then if it's way off, then you probably did something crazy, like you didn't take the square root at that part, or you squared the variance, instead. Does that make sense?
So would there be a situation where it would be considered statistically significant, maybe with the SPSS output, but not with your hand calculations? Can
No.
those two not agree? No, they should be
No,
same
it
answer.
should be exactly the same. Yes.
Okay.
Exactly.
Okay.
So, yeah, so your hand calculation and your T should absolutely match up 100%.
Okay.
And so, so this should be the same as your hand calculation. So that's a good way to guide you, for example, on your test or when you're practicing or anything like that. This is reflected in the critical value table. Right? And so instead of calculating P, they just calculated the minimum T because I mean, you couldn't really, yes, if it's significant here, it'll be significant there. It all coincides.
Okay. I think I got off on the weeds on that Nike and Reebok example, because one said yes and one said no. And I was like, okay, is that okay? It doesn't seem like it should be okay, but
Well, that was different though. That was,
Oh.
one was within subjects and one was between subjects, right?
okay, yeah.
Yeah, so that's different. So
Okay.
that might have been the same data, but doing it in a different analysis. So with the within subjects, you need less participants to show a statistically significant difference because you have less error variance. It's a whole thing, but you can,
Okay.
if you take the same data and use it as a within subjects test versus a between subjects test, get a different statistical result, draws a different statistical conclusion. But that is not the case when it's the same data and you just do it by hand or in SPSS.
That makes sense. Thank you so much.
Yes, no problem at all. Any just lingering questions before we go on to within?
I have a good question, Dr. Bennett.
Sure.
So when we're finding the critical value, we are just going to refer to it in our textbook, just like what we were doing with finding the significance within our Z-scores from last exam.
Yes, so the table for this, it's a different table though.
Yeah.
So the table for this is still in Appendix B, but it's page 359.
Gotcha.
But it's the same thing. So if you look on that page, you will see the critical values for the, 359, it's 357. So 359 is for NOVAs, 357 is for t-tests. If you look at page 357, you'll have the degrees of freedom. It'll say t-values needed for rejection of the null hypothesis. And it'll have degrees of freedom down one side, and then your alpha, your alpha levels going across.
Gotcha. And my second question, so when we're doing a t-test, it's only when you have two independent variables?
It's only when, no, independent variables
no.
are different. So a t-test, you do a t-test when you have two, when you're just comparing two groups, right? So you're comparing the means for two groups. And there's two different kinds of t-tests. One is an independent samples t-test where the two groups that you're comparing have different people in them, right? So class, Dr. Witten's class and Dr. Janowski's class, that would be an independent samples t-test, right? Because there's completely different people in each of those classes. Within subjects or dependent samples t-test is when say you took my class and we did before and after looking at a statistics video that I made, right? So did you understand the concept before you looked at the video, and then you take a test, and then after the video, did your knowledge improve? So that's the same people, that's the people in my class. It's just before and after.
Gotcha. Thank you, Dr. Whitten.
Yes, no problem at all. And so, okay. And so just give me a second. I'm gonna pull up, I did at least I thought I did yeah, I don't know why that's not coming up. All right. I guess I just did it in SPSS. So we're gonna have to just 1 second, having some setup problems, switching to the dependent samples t-test. Okay, there it is. So somewhere on my desktop. Okay. So hopefully you can see my desktop here. And so here's a different scenario where we looked at the employability of students before and after they took the NACE competency class. So here, first of all, this is within subjects because they're the same people, right? So they're the same people, we're just going to measure them at different times. And so here we had them take that same employability test, and then they were introduced to the NACE competencies, took the class, and then their employability afterwards. So we can analyze that in SPSS by going to Analyze, Compare Means, Paired Samples t-test. We put them in side by side. Right, so we're going to compare, the pair that we're comparing is before and after the NACE, and then it will come up like this. It looks really similar to the independent samples. We've got our means and standard deviations up here. Where you need to look is down here. Do I have an annotate thing here? Is down here. Really, these three are the most. So in this one, because we have a directional hypothesis, you would assume, you would hypothesize that people who took the class would actually be better after the class than before the class. And so that's directional. And so here's the information that you would need. Now, calculating this is actually pretty easy, believe it or not. And so to do that, we're going to do it. We're going to do a lot of it anyway in Excel. Yeah, my cat is just not going to leave me alone. It's just not going to happen. Why can't I want to go back to a mouse. There we go. So I'm going to just copy this data over, and I'm going to put it into an Excel file. That annotation is not going to go away. Hi, honey, you can't sit here. Okay, so here we go. So this is our pre-test. It's always hard to do stuff when I'm trying to do it fast. All right. So this is our pre-test, our post-test, and then we're going to get different scores for each subject, and then we're going to square those different scores. And so the first thing that we just need to do is subtract row 2 from row 1. And so in Excel, that's super easy to do. Now, on your test, you'll have to write all of this out, but you can calculate it in Excel beforehand. I need to see that you know that you've got to subtract each of those values. And, you know, I mean, you've had tests with me before. You've had 2 tests with me before now, at least. So, I mean, they won't be very long or anything like that. I just need to know that you can do that, right? And so hopefully I wasn't going too fast there, but here we've got, so each one of these, that's 38 subtracted from 25. So 25 minus 38 is negative 13, right? Negative 19 is 20 minus 39. And then for each of these, we square, so 13 squared is 169, 19 squared is 361, etc. And then just for these 2 columns, you just need to sum them up. And so when you sum up the columns that you just created, your D and your D squared, you'll get negative 85 and 7,225. And so with that delightful information, let's go back to the whiteboard. To the whiteboard. I feel like I need a whiteboard jingle or song or something like that. Da, 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 to the whiteboard. It's the Shannon Statistics Show. Wow, I'm tired. I'm just coming up with all kinds of crazy nonsense. All right, so we calculated that the sum of the, I should put this on there, the sum of the different scores was negative 85, and the sum of the different scores squared is, what do we have there? 7,225. Right. That seems right anyway. Is that right? Yeah. All right. Sorry, little moment of paranoia. It's okay. So the formula for dependent samples t-test is the sum of the d-scores over the square root of n times the sum of the d-scores squared minus, and hear my tone, the sum of the d-scores, threw off the tone, the d-scores squared, right? So the sum of the d-scores squared, the sum of the d-scores squared. Yeah, you're welcome. All right, so here's the formula. Now we just, as usual, we get to plug in numbers and just have fun with that. So we've got negative 85 for our numerator. That's the sum of our d-scores over square root. The n was 10. And the sum of our d-scores squared. Yeah, I don't know why, like when I wrote this down, this does not look right. And so I'm kind of freaking out right now. I don't know, let's just go with it, right? Hold on just a second. Something's not right. No, I did do this before, but that looks right. So hold on. Can you see my screen? Probably not. It's fine. It's nothing to see here. Nothing to see here. Ah, that's why. That's why it didn't look right. All right. So what can I say? I'm a stats teacher. I can teach stats, but I'm not a genius. It's fine. So when I carried that over, it squared this, and I'm like, I know that number is in this, but it's not in this at the right time. Yeah, so you actually need to add this up and not just square that. So Excel is nice, but you need to make sure that it's all plugged in right. So the sum of this column should be what's here, and that is 1,109. So back to reality. Okay. So that's what goes there. Minus. Over n minus 1 is 9. And way too much over there. I'm just trying to make some room. So now this is going to be 11,090 minus, here's 7,225 over 9, which will work out to 3,080. Oh, sorry, 806. Oops. 65 over 9, which will work out to 429.44. Of course, that's under a square root, so we've got to do that. When we do that, we should get negative 85 over 20.723, which works out to our t value of 4.102. Yay! And then cue the theme song. We did it. All right. That was a bit much, but yes, this is our calculated value. And so we've got this to determine if the NACE competency course was effective in increasing employability in students. What would we do? You're experts now. Oh, come on, we just did this. What we do?
Going back to our chart.
Go back to our chart. Yes. Thank you, Amy. We'll go back to our chart on page 357. Right. We have 9 degrees of freedom, and this is a one-tailed test. We want an alpha of 0.05. And so here we have a critical value of 1.833. So what do you say? Can we reject the null hypothesis and say that there are statistically significant differences?
Yes.
Yes, we can. Yes, because 4.1 beats 1.8 every time, because it's always going to be a bigger number. So yes, the bigger number wins when we're looking at the critical value. So yes, we can say that the NACE class was effective, that students did increase their employability ratings after taking the class. Right? So kind of just to reiterate this, just to drive this point home and to make you guys feel like you have got this, because I know that you do. Can you see SPSS output?
Yes.
Good. Okay, so where would we look here? to tell if there are statistically significant differences between the pre-test and the post-test.
The p-value.
The p-value, right? Which one would you pick for our one-tailed test, our directional hypothesis?
0.001.
Yes, yes. So if you have a one-tailed test or a one-sided p, if you want to use SPSS parlance. Want this, yeah. So this is directional hypothesis. And this is non-directional hypothesis. Wow, this is bad writing, but it's okay. Right. So anytime you know which mean beforehand should be higher, right? Or you think you know you're hypothesizing one mean would be higher, you use the one-sided p for the one-tailed test for the directional hypothesis. Anytime you are not sure, you know, let's say it's something different. Let's say it's an experimental program to increase career competency and you just don't know if there is, if, you know, that if the program might make them worse. I don't know what you'd be thinking, but okay. If you're not sure which mean would be higher, you choose this one. And that is your t-test lesson in a nutshell. So definitely, as you're reviewing for your test, for sure, I mean, the calculations are important, but just as important is understanding, you know, the differences between between subjects and within subjects, all the synonym for those, you know, within subjects is also paired samples, and the other one, and within subjects, paired samples, etc. I can't think of it, but that's only because I have a cat distracting me. Right? Between subjects is also independent samples, and so on. Right. So, and know really what the difference there is. So if I said, you know, you've got one group of voters and you want to know if their stance changes on an issue after hearing a certain campaign, so you test them before and after they hear this wonderful campaign. Would that be paired samples or independent samples?
You said same people, right?
Yep, same people.
So paired or within.
Within.
Paired within and dependent. Yes, that's what I was
Okay.
trying to think of. Yeah. So paired within dependent, right? So so yes, because of the same people and you're testing them at two different times before and after, this would be an example of a paired samples test. Now, what if you have that same political campaign and you want to know if people in Brevard County differ from people in Orange County? What would that be?
That would be, wouldn't that be independent?
That would be independent, right? Because, you know, presumably the people who are residents of Brevard County are different people from the residents of Orange County. So you would use that, you would compare them using an independent samples t-test. Very good, Letitia, and everybody's done really well. So make sure that you know and reiterate those when you use, you know, what one or the other of those tests. If I were you, I would start this early. And of course, I'm probably preaching to the choir because if you're here on a Friday afternoon voluntarily, you know, you're probably, you know, not, you know, like you're probably not slacking on your studying typically. And so, but, you know, to all you viewers out there as well, you know, we're going to go over, you know, this is the, I mean, I hate to put it like this is the hardest test, but this is the test that kind of covers the most meat. And so we're going to go over ANOVAs next week and then, you know, understand designs with more than one independent variable. So we still have some pretty hefty stuff to add to your knowledge for this next test. So definitely kind of make sure that you're current with keeping up with your readings and your understanding of what these tests represent, how to look up the, I mean, the good news is the p-value is always a p-value for whatever test, right? P always has to be lower than the alpha level no matter what. And, you know, your calculated value always has to be bigger than the critical value. So that part's good.
I have a question.
Yeah, sure.
Would this be the right time to ask about the F value, or would that be next week? Because I understand the calculations, but when I get to that part, it's gone.
Okay, yes. So I am going over that next week. So it depends on what kind. Do you have a very involved question about it where you need me to go through multiple calculations, or do you have like a simple question?
No, I know how to do the calculations, but it's just when I get to the F value,
Mhm.
or even like one of the charts that you had in the practice exam, I believe,
Okay,
is finding the F value. But if I don't know how to find it after doing the calculations, I definitely can't do it looking at the chart that you submitted or presented on the quiz exam.
well, the F value is just the last step in the calculation. So you're
Right.
talking about the source of variance table where it's like between, within,
That one, yes.
that one. Okay, yeah. And so the very last column, that last part is the F value.
Mm-hmm.
So you've got your sums of squares between and within, and total degrees of freedom between, within. And then your mean square is calculated by dividing the degrees of freedom into the sum of squares. So you get your two mean squares,
Mm-hmm.
that third column, and then you divide your mean square error into your mean squares within, same thing, right? Mean squares within into your mean squares between to get your F value.
Okay. Hold on.
So here, I mean, I know it's a little bit early, and for those of you who might be freaking out a bit because it's too much, that's okay. I mean, I am going to go over this step by step next week, but if you just want to like casually, so to calculate your ANOVA, you've got your sums of squares between, sums of squares within. Here, let's see. You know what? This is terrible. I'm going to just do this in Excel because nobody wants to see me write things out because it's terrible. It's just terrible. Right? So here we go. Right. So you always have between groups and within groups. And then total. And then you're going to have sums of squares. Why does technology never obey me? It's awful. It's like it has a mind of its own. Terrified. All right, degrees of freedom, mean squared, and then you finally get your F ratio. So I'm just making up values here. Let's say your sums of squares between groups is 10, and your within groups is 12, is 2, right? Okay, 2. I'm just making up numbers. Who cares, right? And then your total would be 12. And then degrees of freedom is 3 and 1. I guess it would have to be, right? And then actually I'll do 2 and 1 because it's easier to calculate, right? And so your mean square is going to be 2 divided into 10 for 5. And then your mean square within groups, which is also called mean square error, by the way, which I think makes it easier to conceptualize, but that's just. And so that's going to be 2. Right? And so your F ratio is going to be 2 into 5, or 2 point whatever, 225 maybe. Yeah. I'm a terrible math teacher sometimes because, yeah, 2.5. I can't do math in my head. It's so sad. But here you go. Does that make sense? So these come from complex calculations that we don't have to get into. This is very simple to get, which you'll see next week. But then just to fill out this table, and for the most part, just so you know, on your test, like I'm basically going to give you this table with blanks. So you're not going to have to calculate sums of squares. You might have to calculate degrees of freedom, but it's never too hard. And then, yeah, that's way wrong. And so, yeah, you just have to fill in this table. So these are given through other calculations, and then you divide your degrees of freedom into your sums of squares to get your chi mean squares. And then the F value is the ratio of mean square between groups and mean square between groups and mean square error. And so there's that. So did that answer your question, Letitia?
It did. Thank you.
Yeah, you're like, it did, and then some. You know, that's what you get with Dr. Witten. A little bit of extra.
Thank you. Thank you.
Right, no problem. All right, any other questions that I can answer for you? Well, I thank you all for being here on this lovely Friday afternoon. And so I hope I helped you, and I hope that you have a wonderful weekend. Okay, yes, thank you. Bye-bye, everybody.
Thank you.
Bye-bye now.